As we're examining the relationships that are built into trees and the ways that those can be useful to us, it would be a good idea to think about our binary search trees that we're a little more familiar with and what those relationships in a binary search tree can do for us. To do that, we'll think about the order in which you would need to get items from a binary search tree if you wanted them from lowest to highest. So if you wanted to be able to step through them, like you might a sorted array or a sorted linked list from lowest to next lowest, all the way up to the highest value, what would your sequence need to be? And whether you just look at the tree and you decide the individual values, or whether you've got an idea of a procedure that could generalize, either is fine at this point. But just think about where are the lowest values located, the next lowest, the next, and start to get an idea of that ordering and how we could go through them. So pause, take a moment, think about the ordering, how we would proceed. You may remember from previous discussions about binary search trees that the minimum value will always be the leftmost value in the tree. You go left as far as you can because left means less in a binary search tree. Anything that is less than a node will be to the left of it. And so the leftmost value here would be our 11. It would be the first node that we would visit. And we know that the 95, the rightmost value, because right means greater, the rightmost value would be the last that we visit. From there, it can get a little complicated though, because from 11, we would look at its parent, 18. That would be the second one we would visit. We then could not visit its child. We would have to visit the leftmost node under its right child. Doesn't that sound fun to have to navigate through? So the third that we would visit would be the 22 there. And then from there, we could hit the 31, which is between 22 and 40. So the parent of that gives us the next value. Then the 40 gives us the fifth value we would encounter. Then we have to hop all the way back up to the 50, to the root, to get the sixth value. You can almost sort of see that it's going to parents until there's one that hasn't been used yet. So we'll look more at how we could actually implement that. But that's the general structure, the way that the relationships of the binary search tree are giving us this ability to get a next highest and next highest value. So now we're doing that weird trick again where we do have to look to the right because that's all that's left. What a fun way to say that. All that's remaining. Then we look at the leftmost node in that right subtree. So 67 is the next value sequentially. Good for us. So 67 would be the next value we look at. Then the 79, the parent there, be the eighth value. And we knew all along that the place we would end up would be the rightmost node. And so that will be our ninth and last value that we would get from this. What we've just done is actually called a traversal. Just like in an array or a linked list or things like that, something that's linear and sequential, we can iterate through, and that's called an iteration. This is called a traversal. So navigating through all nodes in a tree in some particular order. And we'll look at different traversals and the different orderings that they give us and why we might want this traversal in one situation, that traversal in another. We have seen that for a binary search tree, we can do an in-order traversal, meaning that it gives us the value of those nodes in the binary search tree from lowest to highest. So in order traversal of a BST gives us the tree's values from lowest to highest. Now, how do you actually do that traversal? That's what you're going to examine as you look at things in the activity. But we see that it's possible. We see that in a binary search tree, the structure and the relationships built into it allow us to get things in order from lowest to highest. And there are other structures of other trees, like our expression trees, that might allow us to do interesting things in traversing them. So traversal just means some way to get through all of the stuff in a tree, because it's complicated. When a tree is a root with some children, and they might have children, and those might have children or might not have children, knowing where to stop and where to go to next, like after our 5th node here, how did we get to the 6th? These rules can be complicated. It'll turn out that to do it recursively is actually usually not too bad, but that those recursive ones have some limitations too, and we'll see some examples of those both in the activity and in some of the later work you'll do in the class. But for now, you've got sections B and C of the activity, which will walk you through traversals and will also to get you to think a little more about how you build the structure of some of these trees and how you represent those relationships, so that then we can do things like traversals that give us the data out of the tree in a meaningful and useful way.